Anyone please confirm whether this PPT slide is visible to all? Can anyone please quickly confirm whether my
Yes,
screen is visible? Okay, so I'm proceeding with it. So basically, the objective of this upcoming 5G training batch will be to understand, vendor-specific 5G RAN architecture. So talking about the vendor-specific, we will start with Ericsson system first. We'll after summing up and after completing this Ericsson system, the second vendor we will go a walkthrough will be the Nokia system. So mainly Ericsson and Nokia will be covered. So we'll start with the Ericsson system. Apart from the architecture design, architecture principles, we will be covering the all the SKPIs, the master key KPIs, their counters, their cost codes, parameter optimization, advanced level of troubleshooting. LT, I know in day-to-day deliveries, you would be well aware of the black and white key concepts of LT. So this will be for the specifically for the 5G technology. So this will be the objective. So basically, this training module is divided into 6 modules. Sorry, a little bit of my distorted voice. So this training module will be divided into 6 modules. Here I have mentioned all the 6 modules. So first module will be covering up the architecture of 5G, the performance framework. Second module will be covering the accessibility optimization, basically the first step by which your handset will access the 5G network, the optimization of the accessibility part. And then we will move towards the retainability optimization. You all must be aware about this retainability, accessibility, mobility, and integrity KPIs in the LTE technology as well. Same terminologies will be used in 5G as well. The fourth module will be covering up the mobility optimization, basically the handover procedures, the handover failures, the handover success rate, etc. Purely for the mobility part. The fifth module will be the throughput optimization, which is the very critical part, because whether talking about the 4G or the 5G, your main goal is to deliver a seamless data experience at the customer end. And the last module will be the end-to-end performance and troubleshooting. Basically, I'll be showing the case studies that you may face in your day-to-day deliveries. What are the issues being faced, how you troubleshoot it, and basically, what will be the expectation of the customer. So these are the broadly 6 modules that will be covered up in the upcoming 5G training module. So we'll start with this module first. But before proceeding directly for the 5G, let me, in order to make this demo session interactive, I'll just sum up with the the comparison of 4G versus 5G. I know all you are basically aware with the fundamental concepts of LT, and few of you have gone through the some concepts of 5G as well. And this will just outer line summary. I'll not go in detail. Detail and all will be will be covering up in the module. So talking about comparing this LTE and 5G, or the difference between the LTE and 5G. Talking about the standard, you well aware about the 3GPP standards. Like 3GPP release 8 to 14 is meant for the LTE. Talking about the standard, while release 15 and beyond is for the 5G. Talking about the evolution from 3GPP standards, HSPA, high speed packet access, and 5G will be like LTE Advanced Pro. This is the first point. If we want to talk about the standard and evolution. Second, talking about the network architecture. Talking about the network architecture, the access part, the first access through which handset access the LTE network will be the EPC, Evolved Packet Core. While in 5G, it will be the 5GC, 5th generation core. This is the new introduction in 5G. Talking about the architecture type. See, architecture in LTE, it is like fixed, it is flat, it is centralized, basically. While talking about this 5G, it is cloud-based. It is the cloud-based. You might have heard the terms like edge computing, virtual cloud. This architecture, basically we can say as service-based architecture, cloud RAN or edge computing. Basically, this technology 5G, it supports the virtualization, while the LTE, it is the fixed kind of thing. Now talking about the spectrum efficiency. Spectrum efficiency, LTE, we can say that it is mainly like below 3.5 gigahertz. Frequency range just limits for below 3.5 gigahertz. In 5G, we have total of 2 frequency ranges. One you can say as FR1, One you can say as FR2. I know the screen which you can see, it is not showing up the points which I am conveying. I purposely haven't included that because just starting anything just to make you familiar with the concepts you might have already gone through, the basic difference between 4G and 5G. So continuing to that, we have two frequency ranges in 5G, FRN and FR2. Frequency range one, basically it will be under the range of less than 6 gigahertz, and for FR2 it will be millimeter wave, wave, 24 to 100 gigahertz. You might have heard about the term millimeter wave. Talking about the duplex mode. Duplex mode in 4G and 5G, both they use frequency division duplexing and time division duplexing, FDD and TDD. So what is the difference when they are using both the same duplex mode? The difference is the very thin line. Basically, one simple difference is there. This 5G the TDD, mainly in 5G, it is used for 5G NR. In LTE, you're using the both duplex modes, FDD and TDD. But specifically, this is TDD. This 5G use TDD. FDD will be as it is. Talking about the modulation techniques, downlink and uplink modulation. Downlink modulation, you have like QPSK, quadrature phase shift king, 16 QAM and 64 QAM. So max to max, there will be in LTE 4G. We have the limitation of this modulation technique as 64 QAM. But in 5G, you have higher modulation scheme. Apart from this QPSK 16 QAM and 64 QAM, you have the introduction of 256 QAM. This is the higher modulation technique. Now talking about the multiple access, LTE downlink, okay, it uses the OFDMA, orthogonal frequency division multiple access, and for uplink it uses the SCFDMA, single carrier FDMA. But for the 5G, for both downlink and uplink, it uses OFDMA. Like for downlink and uplink, this LTE uses the two different multiple access, but 5G will be the common one, OFDMA, whether it may be downlink or it may be uplink. One big difference between 4G and 5G, you might have heard this term as sub-carrier spacing, SCS. Sub-carrier is nothing but this defines the frequency separation between adjacent sub-carriers in an OFDM-based system, LTE or NR. So basically, is the frequency separation between the adjacent sub-carriers. So talking about sub-carrier spacing in LTE, this is fixed. This is of 15 kilohertz. You don't have any leverage, you don't have any liberty in sub-carrier spacing. You have a fixed sub-carrier spacing of 15 kilohertz. This is for the LTE. But in 5G, you have flexibility. You have a very great flexibility of this sub-carrier spacing. Starting with the 15 kilohertz, unlike in LTE, it goes up to 30 kilohertz, 60 kilohertz, 120 kilohertz, or max to max of 240 kilohertz. This is the one of the major difference between LTE and 5G. Last, if I talk about the MIMO, you might have heard multiple times this MIMO, multiple in, multiple out. MIMO and the beamforming. So if I talk about the MIMO, LTE, it uses in downlink, it uses the configuration of maximum configuration which LTE uses 8x8. But in LTE, this MIMO configuration goes up to 64x64. This is the maximum MIMO configuration which 5G can use. 5G can accommodate is 64x64. Basically, 5G we MIMO word, if we use in 5G, then we don't use the word as simple MIMO. Rather, we use the term as massive MIMO. Basically, massive MIMO. So basically, this is the basic difference between, or you can, if I compare LTE with 5G, what are the advantages of 5G over 4G? So these were the few of the points which I have covered up. Getting back to our demo part, modules I have already covered. 6 modules will be there. So just to give you a brief idea on the module 1, because we'll be starting with the module 1. Module 1 will be for this architecture and the performance framework. So what will be covered in module 1? We will be covering up the 5G radio access network overview, 5G RAN overview. We will be then covering up the core network elements of 5G. Then we will see what are the interfaces that's been used in 5G technology. We will see the functional splits. We will see the key parameters. What are the parameters that we will monitor? We will troubleshoot. So that part also will be covered. Then we will see the 5G deployment strategies, how the 5G technology being deployed in the market for a particular operator. Service, SA, NSA, standalone and non-standalone. And last but not the least, performance KPI. Depending on the demand or whatever the concepts I'll come through, I'll add some extra part in module 1 But this is just the broad points which I have covered in order to kick off this session with module one. So 5G RAN overview, core network elements, interfaces, fourth is functional splits, fifth are the key parameters, sixth is the 5G deployment strategies for standalone as well as non-standalone. And last but not the least is the 5G performance KPIs. These will be the part of module one. Then subsequently, we will go for the individual KPI analysis, accessibility part, retainability part, mobility part, the integrity part, throughput, we can say yes. And last but not the least, end-to-end performance troubleshooting. And you guys will be excited to know, like, the training session of RF is not just based on the, theoretical knowledge, just kind of a bookish knowledge, because that part will not give you the real insights of what's going in the network, how we troubleshoot, how we work, how things being delivered. And it will be a kind of, a kind of boring session. So in order to make it interactive, apart from this, key concepts, we will show you a live demo for the OSS. What are the commands being used? How you see the counters? How you monitor the alarm? How the KPI is being reflected in ROP-wise manner. 15 minutes duration, 30 minutes duration. Basically, live OSS we will be showing you all. Lab part, basically OSS part will be covered. We will be also displaying you the dashboards, the KPI dashboards that operator use, or the dashboards which usually being discussed in the customer call, or basically what the customer, how to present your KPI data to the customer. Because talking about the operators like Bharti, I worked extensively with the Bharti Airtel VI also. So they have very sharp, they have very stringent demand of how the data being presented, how you're gonna show the pre versus the post results, how you're gonna show the improvement in the network. Basically, you will be using system, the operator, the customer will be 100% rely upon your skill, your competence. It has a huge expectation in this competitive market. So those all parts will be covered. In continuation with the module one, architecture and performance framework. Guys, just give me a moment. Okay. Sorry. So basically, starting with the 5G network and the performance. Basically, 5G, the principle of 5G is to deliver ultra fast speeds, ultra low latency, and massive device connectivity. I mean, if you talk about LTE, the number of devices, the maximum limit LTE will have. This 5G offers, more and more bandwidth, more and more capacity to encapsulate more number of users. Basically, it has a very broad dimension, and in order to deliver much and much better quality of service experience towards the customer as compared with the traditional LTE technology. So talking about the 5G system architecture, as I told you that, RAN architecture and all that part will be, performance part will be covered in the module one. So just briefing you all about this 5G system architecture. Basically, in LTE, the first access point is the E node B. 2G and 3G, which you called as 2G, in which you called as BTS. In 4G, it is called as the E node B. 5G, the term is replaced by the G node B. Next generation node B, G node B. So what is the difference? This G node B in 5G, this is split up into two parts. G node B is split into two parts. One is CU, the central unit. Another is the DU, distributed unit, basically. So the central unit, it used to manage the higher level of protocols, like the radio resource controller, PDCP, the packet data convergence protocol. While this distributed unit, it used to take care for the real-time task in the MAC layer, in the RLC layer, for the low latency of operations. Low latency means basically in which, the delay should be as minimal as possible, as minimum as possible. So talking about the core network, when we were just a few moments ago, when I was comparing this LTE with the 5G, I used a term called the architecture, basically. Not the architecture, the deployment. Basically, deployment, if you talk about the, okay, I just use the word as architecture itself. Architecture in LTE, as I conveyed earlier, that LTE architecture is primarily the hardware based, while 5G, it is the completely the cloud based, basically, as computing, which we say. So 5G, basically, it is the service based architecture with functions such as, access and mobility management, AMF, UPF. In detail, we will be covering in the first session of the training part. So talking about the deployments, how is 5G technology being rolled out in the market? There are two modes for it: standalone as well as non-standalone. SA or NSA, we can say in short term. What is the basic difference between SA and NSA terminology? This SA, if we talk about the standalone deployment phase, in this, the core part, basically the brain of the network, the core part will be completely 5G based. This standalone will not use any kind of legacy technology, while in non-standalone, the core part will be of LT. Core part will be of LT. Your messages will go through the LT core part. LT core infrastructure will be used. So this is the basic difference between NSA and SA deployment. Talking about the 5G performance requirement, I'm sure that you might have gone through, various certification, various courses, or the videos which you've gone through. But just in order for a quick summarization, I have just included the performance requirement parts. So talking about the performance matrix, whether you talk about the peak data rate, whether you talk about the reliability, whether you talk about the mobility, anything, these are the minimum requirement and how they're being used, in which category they're being used. For example, if I talk about the peak data rate, 5G in LTE we used to measure it through Mbps, but in 5G you have gigabits per second. Downlink maximum max to max of 20 Gbps can be achieved, uplink 10 Gbps can be achieved. So this much of high downlink and uplink speed, where to use it? We can use in enhanced mobile broadband. Then talking about the spectral efficiency in downlink, it is 30 bits per second per hertz. It's 15 bps per hertz. These are also, this is also being used in enhanced mobile broadband. So talking about the enhanced mobile broadband case category, we have peak data rate, we have spectral efficiency, and we have user experience data rate. Talking about the next category, the next case study, the next case category we can say is the ultra reliable low latency, URLLC. This ultra reliable low latency, basically live example which I can state is the remote surgery in the medical profession. For example, if the qualified doctor is sitting in one location, but he has to perform a surgery to a distant location. So how technology can help towards in the execution of a successful operation surgery. In that comes the ultra reliable low latency that comes into play when we use the term as ultra reliable low latency. So obviously, as a common sense, the delay, the latency which you talk about, this should be negligible or as less as possible, basically. So the user plane, this latency 5G plays a very key role. The next is the reliability. And in continuation with the enhanced mobile broadband EMBB, we have the mobility and area traffic capacity also. This area traffic capacity, as I told you, this capacity is much and much higher than our traditionally or legacy technology LTE. Basically 10 Mbps per square meter in hotspots. Talking about the availability, the radio network availability, this should be, because 5G has very stringent demand, this should be 99.99%, or you can say, because if I use the percentage as 100%, 100% is such an ideal situation. You will have the outages in the network, you have the downtime. So 100% will not be the correct figure. Rather, I have used as 99.99%. Basically, the idea is to convey, the availability should be maximum. There is no place of, higher outage duration in 5G technology. And this availability, it doesn't comes under any of the case category like, enhanced mobile broadband or ultra reliable low latency. This should be under all. Unless and until you're going to have the seamless mobility, you cannot perform, you cannot expect any of the case category to run in a smoother manner. So basically, these are the basic 5G performance requirement. Now talking about the RAN architecture, the left side, which you can see, is for the 4G network. 4G network, a very very small figure, small idea, which gives idea about the 4G architecture. On the right hand side, this is for the 5G architecture. As you can see, the difference that this front haul part, back haul part, this is for both 4G and 5G. But in 5G, you have an introduction of mid haul also. As I told you earlier, that in 5G, your BTS, or we can say as G node B, this is split up into two parts: the distributed unit and the central unit, the CU and the DU. But unlike in the LT, you have the radio unit and the BPU. Simple. But this is further split into more components: CU, DU, and RU. RU is nothing but a radio unit. DU is nothing but your distributed unit. CU is nothing but your central unit. This is the core part. 5G, 4G core is the 5G network, 5G core network, basically. So front hall, this is the first point. This is the first point of entry in the network. This is the radio unit. So basically, front hall comes between the radio unit and the distributed unit. Mid hall is the part that comes between the distributed and the central unit, and the interface that connects central unit towards the core is the backend portion, backhaul. This GTPU, basically, GTPU, we call it as GPRS tunneling protocol for the user plane. This GPRS tunneling protocol is used to transfer the user data. Basically, we can say that internet transfer, internet traffic between your core network elements and the base station. And that is the function of the GTPU.